What would happen if 100 Viking longships emerged from the mist of the 9th century? Their dragon prows cutting through the cold sea, shields painted in red and black lining their hulls, warriors gripping axes forged in Scandinavian iron, chanting to Odin, preparing for glory, and waiting beyond the horizon. A floating city of steel, a nuclear-powered fortress, a modern United States aircraft carrier, not just any carrier, a Ford-class supercarrier like the USS Gerald R. Ford. This is not just a battle. This is a collision between two entire technological eras. Before we dive into this impossible confrontation, subscribe to Echoes of Empires and join us as we dissect the true mechanics of power across history. Because today, we are not imagining fantasy. We are testing physics, engineering, logistics, metallurgy, and warfare doctrine itself. Now let us begin with the Vikings. The Viking longship, particularly the Langskip or warship, was one of the most sophisticated naval designs of the early medieval world. Length ranged between 20 to 30 meters, beam approximately 5 meters, draft extremely shallow, often less than 1 meter, allowing river navigation. Clinker-built oak planks overlapping and riveted with iron nails. Flexible hull design that absorbed wave energy instead of resisting it rigidly. Propulsion came from a single square sail made of wool, reinforced with animal fat for waterproofing, plus 20 to 30 pairs of oars for maneuverability. Maximum speed under sail, roughly 15 knots under ideal wind. Rowing speed sustained, 5 to 7 knots. Crew size per ship, 40 to 60 warriors. 100 ships could realistically carry between 4,000 and 5,000 fighters. Now let us analyze their weapons in extreme detail. Primary melee weapon, the Viking sword, often pattern welded. Pattern welding combined twisted iron rods to create a flexible yet sharp blade. Blade length around 70 to 90 centimeters, double-edged. Weight approximately 1 to 1.5 kilograms. Secondary weapon, the Dane axe, two-handed. Blade width up to 30 centimeters. Capable of cleaving helmets and shields. Shaft length 1.2 to 1.5 meters. Spears known as spjots were the most common weapon. Iron leaf-shaped spearheads, used for thrusting and throwing. The Sikhs, a single-edged long knife, for close combat. Bows, self-bows made of yew or elm. Draw weight estimated 80 to 100 pounds. Effective range, 150 meters at most. Armor penetration limited against hardened steel. Defensive equipment, round shields made from linden wood. Iron bores in center. Diameter around 80 to 90 centimeters. Mail armor burnie made from riveted iron rings. Conical helmets sometimes with nasal guard. Now compare this to a modern Ford-class aircraft carrier. Length, 337 meters. Displacement, over 100,000 tons. Propulsion, 2 A-1B nuclear reactors, producing enormous thermal energy converted to mechanical shaft power. Speed exceeding 30 knots. Operational endurance, 20 years without refueling nuclear core. Crew, approximately 4,500 to 5,000 personnel including air wing. Air wing composition typicically includes F-35C Lightning to stealth fighters with an APG-81 AESA radar, A-18EAF Super Hornets with AIM-120 AMRAAM missiles, EA-18G Growlers for electronic warfare and radar jamming, E-D Hawkeye airborne early warning aircraft with an AP-Y9 radar capable of tracking hundreds of targets simultaneously at distances exceeding 500 kilometers. MH-60 Seahawk helicopters for anti-surface and anti-submarine operations. Defensive systems on board include Phalanx CIWS 20mm and 6.1A1 Vulcan Gatling gun firing 4,500 rounds per minute. RIM-116 rolling airframe missiles for short-range defense. RIM-16 to evolved Sea Sparrow missile system. electronic countermeasure suites, decoy flares, integrated battle management networks linked to satellites. Now we simulate Phase 1, detection. The E-D Hawkeye aircraft, flying at 25,000 feet, would detect wooden vessels easily due to surface reflection patterns. Even without aircraft, radar aboard escort destroyers using an SPY-1 or SPY-6 radar would detect surface anomalies far beyond visual range. The Vikings would not even know they have been detected. Phase 2, engagement range. The Vikings' maximum offensive range, about 150 meters with bows. Modern aircraft strike range, hundreds of kilometers. An F-35C, flying at 0.9 Mach, could reach the fleet within minutes. Armed with GBU-1 to pave way to laser-guided bombs, or even simple unguided Mk-82 bombs, or strafing runs using GA to 25mm cannon. A single 500-pound bomb detonating near a wooden ship would cause total structural disintegration. One aircraft could eliminate 10 to 15 ships in one sortie easily. 5 aircraft operating simultaneously could eliminate all 100 ships within approximately 20 to 30 minutes. Phase 3. If aircraft are restricted, suppose no aircraft are allowed, only ship defenses. The carrier's Phalanx CIWS uses radar-guided targeting. Its tungsten or depleted uranium rounds would shred oak holes instantly. Effective range around 1–2 kilometers. Even at 2 kilometers distance, Vikings cannot retaliate. Phase 4, boarding attempt. Even if 5 ships survive and approach, freeboard height of carrier, over 20 meters above waterline. Smooth steel hull, no climbing holds, no siege equipment, no gunpowder. Boarding would be physically impossible. Casualty estimation, Viking side, 90 to 100% loss rate. Carrier side, 0 fatalities. The battle duration likely under 30 minutes total. But here is the deeper analysis. The Vikings represented peak asymmetric naval mobility of their era. They revolutionized European warfare. However, modern warfare is built upon layered defense doctrine, detection layer, air superiority layer, standoff strike layer, close-in weapon system layer, electronic warfare layer. This multi-layered defense makes even modern missile threats difficult. Wooden ships would not register as threats. The technological gap is not linear, it is exponential. The Vikings relied on human muscle energy and wind. The carrier relies on nuclear fission, producing megawatts of continuous power. The Vikings navigated with sunstones and stars. The carrier uses GPS satellites, inertial navigation systems, encrypted communications. The Vikings feared fire arrows. The carrier withstands supersonic anti-ship missiles. This confrontation is not about bravery. It is about physics. Kinetic energy of a 25mm round, traveling at over 1,000 meters per second, vastly exceeds anything a medieval weapon could produce. Yet, there is one final perspective. In the 9th century, the Viking fleet was the equivalent of a superpower shock force. Against England, Francia, or the Abbasid frontier, they were terrifying. Every era has its apex predator. Today it is the aircraft carrier strike group, but tomorrow, hypersonic missiles, drone swarms, cyber warfare, artificial intelligence. Even carriers may one day seem outdated. Power is temporary. Innovation is eternal. So who wins? Militarily, the aircraft carrier wins effortlessly. Historically, the lesson wins, because dominance always depends on context. And history never stops evolving. If you want more deep simulations, where we test ancient empires against modern military power, subscribe now and tell us which impossible war you want next. This is Echoes of Empires, where history meets reality.